All right, boys and girls, here's another quadratic, and the reason why I'm showing you this is it's a big mistake among students. You get a problem like this, you notice it's a quadratic, and you notice that the a is not 1, it's 3. So right away, students multiply 3 times 45, get this really big number, and they keep doing the problem. But what I'm asking you is, whenever you see a quadratic, always ask yourself, even if it's a trinomial, is there a greatest common factor? Because look how much easier it is to solve. There is a greatest common factor here. 3 goes into every one of these numbers, and you're left with x squared plus 8x, and then plus 15 equals 0. And now, this is one of those trinomials that we learned before we learned how to do one where the a was not 1. This has an a of 1. And you can automatically, you don't have to put this into a 4-term polynomial. You can automatically say that it's going to be x times something, and the other binomial is going to be x plus or minus something, which equals 0. So in this case, we don't have to multiply these two together. We could just say, what are the factors of 15 that add to 8? And that'd be positive 5 and positive 3. Look how much easier it is to solve if you get it to be a 1x squared by taking out the 3, factoring out the 3. Now we can just set 3 equal to 0, which doesn't make any sense. So we cross it off, and we have x plus 5 equals 0, and x plus 3 equals 0. Much easier to do. And our two answers would be x equals, we would subtract 3 on both sides and get a negative 3. And here we would subtract 5 on both sides and get a negative 5. So our two answers would be negative 3 and negative 5. Much easier. Last one. Same kind of concept. We have a quadratic, but we have to get it equal to 0. So I subtract 30 on both sides, and I'm left with 30x squared minus 25x minus 30 is equal to 0. Now, before we go ahead and start solving, it's a quadratic, but does it have a greatest common factor? It does. It's 5. And when you factor out of 5, you get 6x squared minus 5x minus 6, which equals 0. Now, was I able to get this quadratic with a 1 in front? No. But you still reduced it enough that it's easier now. Now, I only have to multiply 6 times negative 6 instead of multiplying 30 times negative 30. And 6 times negative 6 is negative 36. And my m and my n, because I have to do it this way now because this is a 6 and not a 1, the two things that will multiply to negative 36 but add to negative 5. Well, let's think. Negative 9 and 4. So again, I keep the 5 on the outside, but I'm going to write ax squared minus, or plus or minus mx plus 4x minus the c equals 0. I'm going to group these and these. And I'm going to keep the 5 on the outside, and I'm going to take out a 3x, and I'm left with x minus 3. Here, the greatest common factor is 2, and I'm left with 2x. Oh, you'd get 2x here, yes. 2x minus 3. And now I can completely factor into 3x plus 2, which was on the outside. I'm going to keep my 5 out there, times 2x minus 3 equals 0. And guys, our last step would be to simply set 5 equal to 0 and then cross it out, set this equal to 0, and set this equal to 0. And then you could solve and get your two answers for x, which after you solved it, I kind of ran out of room, would be x equals negative 2/3 and x equals positive 3/2. And those are the types of problems that you're going to encounter in 9-4.